Let's dissect a real multi-tool agent built on the Azure AI Agent Service, the managed agent runtime inside Azure AI Foundry. By the end, you'll understand exactly how a request flows from your Python client through a model deployment into tool calls and back. We'll look at the components that make it work, where state lives, the failure modes you'll actually hit in production, and the trade-offs and architect ways when choosing this over rolling your own agent loop. This isn't a Hello World demo. We're going to anchor everything to one reference design, an agent that can call a code interpreter, search your documents, and hit a custom function. Cloud services move fast, so treat version specifics here as a starting point and confirm against the current Azure docs before you ship. Here's the architecture. Your Python application talks to a project endpoint using the Azure AI Projects client. The agent service hosts the agent definition and orchestrates calls to a model deployment, typically GPT-4o, running in Azure OpenAI. Two tools are attached server-side. The file search tool is backed by a vector store the service manages for you. The custom function tool routes back to your own code. The key architectural point: the orchestration loop runs inside the managed service, not in your process. You don't write the while loop that parses tool calls and reprompts the model. The service does that. Your job is to define tools, handle function callbacks, and poll for results. Identity flows through Microsoft Entra ID, so no API keys sit in your app. Walk through one request. You create a thread which holds the conversation history server-side. Then add a user message. You start a run, which binds the agent and its tools to that thread. The model decides it needs a tool. If it's file search or code interpreter, the service executes it directly and feeds the result back to the model. If it's your custom function, the run pauses in a requires action state. Your Python code reads the requested function name and arguments, executes locally, and submits the output. The loop continues until the run reaches completed, and you read the final assistant message. This pause and resume pattern is the heart of multi-tool agents. Here's the shape in code. You authenticate with default Azure credential, get an agent's client from the project, and create the agent with a tool set. Notice we attach the code interpreter and a function tool together. The SDK can auto-invoke your registered Python functions during the run when you use the function tool helpers, which collapses that pause and resume into one call. For production, I'd handle the requires action state explicitly so you control timeouts and errors. Keep your function signatures clean with typed arguments and docstrings, because the service uses those to build the tool schema the model sees. A design decision worth understanding. State is managed for you. Threads, messages, run history, and the file search vector store all persist inside the service. That's convenient, but it has implications. You're trusting Azure with conversation data, so think about data residency and retention for regulated workloads. Threads grow unbounded, so for long sessions you'll pay in tokens as history replays into the context window. And because the loop is server-side, your observability comes from run steps and the service's tracing, not your own logs. Wire up Azure Monitor and OpenTelemetry tracing early, or you'll be debugging blind. So when does this design earn its place? The honest trade-off: the agent service buys you a managed loop, built-in tools, persisted threads, and Entra-based security with no infrastructure. You give up control over the orchestration logic and accept some vendor lock-in around the thread and run model. If you need custom planning, complex multi-agent graphs, or full control of the context window, a framework like Semantic Kernel or LangGraph running on your own compute may fit better. For most line of business agents that need a few reliable tools fast, the managed path is the pragmatic call. That's my opinion, not a law. Before you ship, harden against the real failure modes. Runs can fail or get stuck in requires action if your function callback throws or never submits output. So always set a timeout and a fallback path. The model can hallucinate tool arguments, so validate inputs before executing anything that mutates state. Model deployments have token per minute quotas, and a busy agent will hit throttling, returning 429s you must retry with backoff. File search quality depends entirely on your chunking and the vector store contents, so garbage in means confident wrong answers out. Treat the agent as a non-deterministic dependency and test it that way. To recap, the Azure AI Agent Service runs the orchestration loop for you, binding a model deployment to a set of tools, persisting state in threads, and pausing on your custom functions so you can execute them and resume. You traded orchestration control for speed, managed security, and built-in retrieval. Your concrete next step: build a single tool agent first with just one typed Python function, wire up tracing, and watch the run steps to see exactly how the model reasons before you add more tools. Get that loop solid, then layer in file search and code interpreter. And because pricing and SDK surfaces change quickly, confirm quotas and the current package names in the Azure docs before you commit a design. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.